This is lesson 4.6, pre-algebra equations containing decimals. And solving these equations is not really any more difficult than solving the other ones that you've done. We're doing algebra here where we have a variable. In this case it's an x. X minus 3.5 equals 8.7. Now when you've had them before and you've had something like x minus 3 equals 9, remember what we did? We're trying to get rid of that so that the x is by itself. So we add 3 to both sides, and that made this go away, and that gave us a 12. So in order for x minus 3 to equal 9, we had to put a 12 here, and 12 minus 3 equals 9. That's a true statement, so we're good to go. The same is true with the decimals. The only difference is we're dragging along a decimal point with us. So, same thing. We're trying to get rid of the 3.5. So we add 3.5 there. We add 3.5 there. That's the only thing weird about it is you're just adding a decimal to both sides instead of just a whole number. So now we have x equals 8.7 plus 3.5. So let's go ahead and add those. 7 plus 5 is 12. Carry the 1. 11, 12. So we get 12.2 for our answer. When we have something like example 2, where we have 4y equals negative 3.32, remember when a number is multiplied by a letter, in order to get rid of that, we divide both sides by that. And this is where it's handy to have your calculator and take negative 3.32 divided by 4, and we get negative 0.83, and we're done. When we have the next example there, which is example 3, we have 1/2 x minus 2.59 equals 3.81. Alright, and again, we're trying to get rid of everything except the x on the left. So, in the order we do this, we get rid of the things added or subtracted to the x first. And that goes away, and we're left with 1/2 x. And over here, we add those two together, and we get 6.4. Don't forget the x there, like I did. Now to get rid of the 1/2, it's being multiplied, so we divide both sides by 1/2. Okay. And that cancels out. Now, you can do that by hand. 6.4 divided by 1/2. And 1/2 you have to write as a decimal. In this case, it's 0.5. And remember, you can never divide by a number that's a decimal. So we move that decimal over 1, and we move this decimal over 1, and then move it up here for the answer. Okay, as I do this one, a couple things I need to know, or I need to do, is I've got a 5a here, a negative 5a, and a 7a here. That means that I need to get these two together. There's an equal sign separating the two. So in order to move this one, it's subtracted here, minus 5a, so I want to move it to the other side, so I'm going to add 5a here, and that makes it go away, and I'm going to add 5a over here. So that gives me 12a plus 0.61 equals negative 0.89. Alright, so now I've got all my a's over here, my variable over here. Now I've got a number added. Remember, if you've got numbers added to your variable, you get rid of those first. So since it's added, I'm going to subtract and subtract. Those go away. 12a equals, take that minus the 0.61, and I end up with negative 1.50. And now I've got a number multiplied by my a. I can't have that, so I'm going to divide both sides by 12. Cancel those, and I have negative 1.5 divided by 12, and then my a is then negative 0.125. Okay, I'm going to look at example 5, not because it's a new type of doing these. It's just like the example 4 we just did. But I'm going to show you another trick that you can do if you'd like to. In example 4, we dealt with the decimals. We added, we subtracted, we divided, and we just left the decimals the way they are. And if you remember a couple lessons ago, we got rid of fractions and made them into whole numbers. And this time we're going to get rid of the decimals and make them into whole numbers. So this is how you do that. If you don't like dealing with decimals and you want them to go away, you look at how many place values you went over here. So we've got a decimal there, and we went 1, 2 place values. Decimal, 1, 2. Decimal, 1, 2. Decimal, 1, 2. It isn't always going to be the same. It could be that, in fact, let's do that. Let's make this one 0.781, just for experiment here. So we went over 2 here, 2 here, 2 here, and 3 here. You determine which one of these terms has the most numbers to the right of the decimal. In this case, this has 3 decimals. The other ones have 2. You put a parenthesis around the entire thing, and you multiply that entire thing, each part of that, by this one we went over. It's 3 decimals, so we're going to put 3 zeros and a 1. So we're going to multiply 1,000 times this, 1,000 times this. We're distributing. Okay? And when we do that, 1,000 times this is 1180x, plus 1,000 times this one is going to be 240 equals 1,000 times that, 840x minus 781. Now our decimals are all gone, and we can just do our basic algebra in order to solve that. Alright, and then they've got a couple story problems, looks like 2 or 3, and let's go ahead and do example 3. Example 6. The car rental company charges $11 per day. I don't know where that car company is, holy cow. And then 16 cents a mile. 16 cents can be written that way. It can also be written as a decimal that way. This is the way I would like you to do it, as 16 cents. Per mile, which I don't know who does that anymore. If a car were rented for 1 day and the charge was $25.40. Alright, so that's how much, when you brought the car back, you owed. So you drove it 11 miles a day, and the rest of the money was made up according to how many miles you drove the car during that day. And what they want to know is how many miles you ended up driving the car. So we know, first of all, that we're going to pay $11 for the car, regardless of how many miles we drove it. Then we're going to add our 16 cents, and that 16 cents is per mile. Well, we don't know how many miles we drove it. We do know that when we added this amount up and this amount up, we got $25.40 right there. But we don't know what we're trying to find out is 16 cents times what? Times how many miles we drove it, added to the 11 will give us that. So this is what we're looking for. We don't know how many miles we drove the car, so we're going to call it X. Once we do that, then we can go ahead and make that determination as far as how far we ended up driving that. So we have 11 plus 0.16x equals 25.40 0. So we're going to get rid of this first. So we're going to subtract 11 here, subtract 11 here, and that goes away, and we have 0.16x equals, when we subtract this, we end up getting $14.40. Now we're going to divide by 0.16, divide by 0.16, that goes away. So 1440 divided by 0.16 is 90. So 90 miles is how far we drove that car, and it cost us $25.40 total. So that's it for the lecture on 4.6. Oh, one of the things that drives me crazy is if you look on the cell phone usage problem, example 8, they have a picture there. And then if you go to the problem sets, they have the same picture there. And they'll have that same stinking picture of that woman with the cell phone on, like, throughout the entire book. Drives me nuts. But anyway, 4.6.